Hello everybody. So, today's video, parametric surfaces and their areas. So what's a parametric surface? Well, a parametric surface is the same thing as a parametric curve, but they have the inputs of u and v instead of just t. So they're actually going to create more different shapes in three-dimensional space than just a curve would have been. So while a curve can be viewed as just a line that's just going in random directions in three-dimensional space, a parametric surface is going to be more of a plane that's going into random shapes. So here's how you define a parametric curve, or parametric surface, I mean. So you have x, y, and z components, but they all have two inputs. Now, to calculate out the tangent plane, it has to contain both the partial of r with respect to u and the partial of r with respect to v. So remember, that's going to be partial of x with respect to u times I, partial of y with respect to u times j, and so on and so forth for both of those. So it has to contain both of those, so you can just use that as the normal vector to calculate out your tangent plane. I'm not going to review over how to do that again. You should remember that back from the beginning of class. The other aspect of it, if the cross product of those two partial vectors does not equal 0, then the surface is smooth. Now, if it turns out that it's equal to 0 at certain points, that means those particular points are not smooth on the function for the parametric surface. Alright, so we've talked about what a parametric surface is. Now, how do you find the area of one? Because since they're in really funky shapes, it can get more difficult to find the area. So, if a smooth parametric surface, S, is given by that equation, so keep in mind, smooth parametric surface is going to imply that the normal vector is not 0, and u and v is the domain, and S is covered just once. So the surface you're looking at is just covered once for all the u and v in the domain. So if you end up double covering, you want to make sure you discount those points. Then the surface area of the region S is given by this equation. So it's just the double integral over the parameters d and just dA. One pretty straightforward integral. Alright. Hopefully you learned something. See you in class.